Next, we're going to learn how to use level instances in PCG. And this is a really useful technique because sometimes you just don't want to spawn around single assets, but you want to maybe work with something a bit more art directed. Let's say someone else from your team created this level instance. There's like a dead tree and there's some assets scattered around it, but you want to have artistic control where these assets end up, and you just don't want to have it completely random, but still reasonably random. For this, we can utilize both level instances and the PCG framework together to then get access to these assets in this level instance, clone them all over your points, and then say sometimes you don't even want to have a tree, or the tree is smaller, or sometimes you have all 3 rocks, sometimes you have 0 rocks around the tree, and all sorts of variation that make it very easy to take a level instance or take a bunch of level instances ideally and use it to populate the scene in a very natural way. So let's start from the beginning. Again, I'm going to create a PCG graph, and let's also create a new level instance. I have a few Megascans assets prepared here. So I'm going to grab the tree again, place some rocks around it, also some grass. Maybe not the most beautiful arrangement, but it will do right now. So let's select all of that, go to level, create level instance, and then we can set the pivot type to a specific actor. In this case, I want to set it to the dead tree. And then I create this new level instance, give it a name. Now this is all one instance here. And if we want to edit it again, we can press Control E and do our adjustments, save it, and then it's all packed up again. Now, what we need to do in order for this to work in PCG is we need to go to this level instance, go to Asset Actions, and create a PCG asset from levels, and then jump into our graph. In PCG, first we grab the landscape data again, together with a surface sampler as usual, and I don't want to have so many points this time. Maybe something like this, or even less. And now we need a reference to this PCG data asset. We can just drag it into our graph. Now what we can do with it is take our points from the dead tree data asset, use it as our source points, and use the ones from our surface sampler as our target points. And then we can try to visualize this already with a static mesh spawner. All right, there you go. This is the basic setup. And in the point inspector, we can see that we get access to these assets here that were defined on the level instance. But how do we actually filter things now? We could go in here now and filter by each different mesh name or something like that. But that would get a bit complicated because maybe we want to apply the same kind of processing for each kind of rock and not per rock mesh or something. So in order to make this system a bit more useful, we need to also apply actor tags to our meshes. So I just pressed Control E again, and I'm gonna apply a rock tag to all the rocks and a grass tag to all the grass. So now we can separate these streams here with an attribute filter. And let's see if we get these attributes. Actually, I forgot to do something. After you edited the level instance, you need to go back to the PCG data asset, asset actions, and update PCG asset. And then we should see that we have these attributes here that are either true or false, so Boolean. And you can see that they have the values from the actor tags. So now we can use this with a constant threshold, set it to Boolean and equal here, and filter out all the rocks. Same for the grass. You need to set it to true also, same for here. And then let's say we want to apply different transform point treatments to these two streams. So now we should only get, now we only get the rocks here and the grass. Let's actually do the same for the tree, because we also want to have access to this one in the PCG. So again, I'm going to update PCG asset, and I'm going to create another filter here for the tree. Let's debug this. Okay, what we can do now is we can say select points, and we can, for example, define that we only want to keep 50% of the trees. I'm going to merge them all back together. Actually, I can also just input them as separate streams into the static mesh spawner. So yeah, as you can see, for the tree, it's already working. And then we do the same for the, rocks. And we maybe only want to keep 30% of the rocks and 60% of the grass or something like this. And then the tree should have some random transformation applied, so it can be randomly rotated around the upwards axis. It can scale a bit, and it can be also tilted a bit. -10, -10, and 10. Then for the rocks, they can maybe be scaled between 0.25 and 1, and they can be also completely rotated. Bit random rotation on the other axes. And maybe the grass, I would just want to scale between 0.5 and 1, and also apply some random rotation, and also slight tilt. All right, and maybe we say, okay, we don't want to throw away so many trees. We want to maybe keep 75% of the trees or something like that. So yeah, as you can see, just with one level instance and a few PCG nodes, it's not a complex graph. You can already create quite a bit of variation, and you can populate an area of a level fairly quickly. The next technique that I wanted to share with you is about the improved water spline sampler. Since a few versions, PCG actually gives you access to additional information of your water spline. You now also get a depth attribute, water velocity scalar, river width, and audio intensity. And we can use this in the PCG graph to decide, for example, to only spawn certain assets at a certain depth in the water, or at a certain river width or something like that. And in the PCG graph that we're about to create, we will also create a more reliable river spline mask to mask out assets and vegetation that's either inside or outside the river spline. In the PCG graph, we need the get water spline data node. And because the spline is not a child or a component on the PCG actor, we need to change it from self to all world actors, and then filter by class and set the water body river class. And then we also need a spline sampler, and we can see how that looks like. So as you can see, right out of the box, the information that you're getting here from, or the spline data that you're getting here from the PCG network is not really useful for masking. And let me demonstrate this. So get landscape data, surface sampler, and then I'm going to put a difference node, set it to binary. Okay, so let's say these points that you're seeing here are potential vegetation, and I want to cut out the river, right? And currently these spline points that we're getting here from the spline sampler are way too wide, and they are also scaling weirdly with the river width. And even if we change this from subdivision to distance, it's not really giving us useful information to use for masking. And we're going to fix this in a second. So let's create a set attribute node, and let's set the attribute that we want to change to scale, and then also create an attribute of type vector, and output it with the out attribute. Doesn't really matter, because here on input source 2 we're just using the last attribute, which means if you inspect this here, you can always see the last attribute that was set by this node. And if you then connect it to this pin here, this pin will know which was the last attribute that was transformed by the PCG graph. And then you don't need to explicitly input the name here. You can just say last attribute. So we want to set the scale to a useful value. And let's say it's like 150, 50, and 500. And then we're going to create another node that is an attribute multiply, and also another create attribute, which is of type float. And we set it to 0.5 for now. And here we're going to multiply the river width that we are getting from the spline sampler here, from the new get water spline data, which you can see here. And we're going to multiply it with our float constant here. And then we're going to write it back into the river width attribute. Or actually, we can leave it at source attribute, which will reference this one. Then right after our multiply, we're going to create a transfer attribute node. And for the source, we're going to define the river width. And for the target, we're going to write this into the scale.y. And then what you can see here is also can probably still increase this to 500 or something. And what you can see here now is that based on this constant here, you can scale your mask, and it also stretches on the vertical axis. So you can use it very well to mask out other stuff. So let's try this now, and let's put this as our difference mask. And the only strange thing is that the mask that you're seeing here is visually not completely equivalent to what it's actually doing in the differences. Because visually I would put this at 0.4 probably, which would then really cover the whole river width. But in terms of PCG logic, it looks cleaner if we put it on 0.25, for example, because then you still get these points here on the edges, or maybe 0.3 or something like that. This seems to be just like a visual discrepancy, and I found this system still working quite well, but I might also improve it in the future. And I will also probably just make all of this here a subgraph and put it on Gumroad, because I want to build a small library of useful PCG subgraphs for you to download. So keep an eye out for that. Let's also actually spawn some meshes here and now use the information that we're having here from the river to do some additional spawning of assets. For example, we can now filter with an attribute filter based on the what's called depth. We can say, for example, give me all points where the river is deeper than 200 units. So let's say we want to spawn some more assets at this depth of the river, get another landscape data, or grab it from the beginning of the graph, doesn't matter right now. Get a surface sampler, maybe make these points a bit more dense, and then use an intersection of these points with this mask. And now you can see that you're only getting the points where the river is deeper than 200 units. So because here on this point here, or on this point, you can see 150 depth. And then I'm going down to up to 500 depth. And then we can put some meshes there. For example, these Lily of the Valley meshes. Also transform them a bit before. Let's see how that looks like. Right now, if we also want to filter out the meshes that are getting spawned here on the sides of the river, this is because it's not actually taking the depth in the world, but it's just saying, if the river information that I'm getting at this point is deeper than 200 units, then spawn it on all parts of the river here. So it's not actually saying, okay, mi as a point here deeper than 200 units, but is the river in this part here deeper than 200 units? So if we also want to filter out these edges of the river here, we could use a normal to density node and then a density filter. And then just fine tune the values here basically. Until it fits better. So now we are only getting vegetation on the river floor basically. And of course for these trees here we could do the same. Just gonna copy these two over here. And that should fix it. Let's clean up here a bit. This was spruce. This here is the lily of the valley. And then we can create another surface sampler here. Get the same landscape data. Maybe change the seed a bit. I also want another normal to density. And I want to filter out for the stones. I want to filter out the points here on the slope. Let's actually make the bounds a bit bigger to see this. And then if we just invert, it's easier. So something like this. But now you also get the you also would get the stones on the slope of this regular landscape hill here, which is not what we want. So in this case, we can take an intersection node, and we can use this as our primary source, and then this river mask here as our source 1. And what that will do is it's taking the intersection between this mask here and all of the points that you're seeing here. And since this mask is not in this area, it's just on the river, it's giving you exactly what we want right now. Create another static mesh spawner and also a select points node. Just want to keep maybe 20% of that into the static mesh spawner and then change it to a boulder. And then of course we would also use the transform points, etc., etc. So now we have these boulders here on the slopes of the river and these plants on the ground. And we correctly cut out the river in our landscape by adjusting the river mask by this little adjustments and multiplications with the river width attribute. Next, I would like to show you an improved way of setting up mesh sampling. We also talked about this in the first PCG tutorial, but I improved this setup here a bit to make it more convenient. So you can now go in here and change the asset that's being sampled, and it propagates through the whole graph. So you can change the base mesh, you can change the overgrowth assets. Example, can change this to some grass asset here. And then we would only have this grass asset that we just set. So it's pretty flexible setup like this, and I would show you how you can set this up. And then in the new graph, we're gonna create a parameter for the base mesh. This time we keep it a single parameter. Could also do an array and then decide like a variation of base meshes basically, but for now we're just gonna use one, call it base mesh. And I'm gonna put a boulder here. Then we're gonna grab the base mesh here. And we need to convert the attribute set to point. Then we're gonna get an attribute from point index. And the attribute that we're interested in here is mesh. And we're gonna write it to the static mesh attribute like we've done before also. And then we're going to have a mesh sampler node, and we're going to override the static mesh attribute here. Next, we need the points that we use as the base points for our base mesh. So just the standard setup here with the copy points node. Then the source is our mesh sampler, and the target points are these points. And this is probably way too dense. All right. Now, if we debug this copy to points, we can see that the mesh that we are inputting here is already getting sampled, but it's not being displayed yet in the scene as a mesh. And in order to change this, we need again the match and set attributes node. And we're just inputting the data that we're getting from our base mesh. And then we put this into a static mesh spawner that we, of course, again need to set to accept the attribute mesh. So now that we have everything in the scene, or at least the sampled base mesh, we can play a bit with the parameters here. For example, I would set it to Poisson sampling and maybe change the sampling radius to 2, and then also add a transform points here. Actually, we want to do this here, so it propagates both to our spawn static mesh and to the copy points. Then we can create some scale variation here. And I would also like to have a few more points. And some rotational variation. And exaggerate the scale a bit also. Now let's also create a parameter for the overgrowth. It's of type mesh data new, and it's an array type. And here I'm going to put again the lily mesh. Into a transform points to actually also control the parameters of the overgrowth points, and then into a static mesh spawner. And then we need to also match and set attributes on this stream here. And here we get the overgrowth. And set this to the right values here by attribute again. Select the mesh. This is taking time to load, probably way too many points. I can't see this right now here because the window is too small. But I'm just gonna go in here into the Poisson sampling and put this to 8 for now, something like this. And then change the scale to something between 0.25 and 75, something like this. And that's the setup basically. Now you can go in here, change the base mesh like I showed before. It will all dynamically adjust. And also, of course, change the overgrowth like I showed before. Nothing changed. The last technique that I wanted to show you is not so much a technique, but more like a quality of life improvement when working with splines. Let me show you what I mean. In this graph here, we have a get spline data node, which is set to self. And then on the spline sampling actor, I mean on the PCG graph actor, I just added a spline component, which you can see here, which then gets picked up by this actor filter self. And then I'm adding a spline sampler here. Now, as you can see here, the points that you're getting from the spline sampler are stretched along the spline, and sometimes this can be a bit annoying because if you, for example, want to apply some transforms to it or some spatial noise or something like that, it's really hard to see what's going on here, and it's not really clear where are the points, what kind of density they have. It's like not really easy to see, right? So I found this pretty simple setup here. We have this bounce modifier here that just sets the bounce between -1 and 1. And then we have another set attribute node, which takes the scale of these points and sets them, also outputting on the scale, to the attribute that we are creating here. So we're just creating a vector attribute, and now we can just define how big our points on the spline will be for visualization purposes, for example. And then if we apply some spatial noise like so, we can actually see what's going on. We see all the density values way better. We can then also use it to spawn these meshes on it. And before we do this, we apply some new scales to it. So basically all of what's happening before here is just for visualization purposes and for making the spline better to work with, in my opinion at least. In terms of actual spawning of the meshes, it makes no difference. So even these seemingly messed up stretched points here that are stretched along the tangents of the spline, they produce the exact same output of spawned meshes. But I find that doing something like this here can sometimes be useful for being able to work more easily with the spline setup. And for today, this is all that I wanted to show you. This is the beginning of a series. I want to extend this intermediate PCG series. I hope you enjoyed the video. If you did, please give me a like and a subscribe, and see you next time.